Everyone, notes 5.4 are on factoring by GCF. And before we can do our notes, we need to fill in what GCF even means. So GCF stands for the greatest common factor. Okay, so we're going to find the GCF of the following, and then we're going to divide each number by the GCF. So to find the GCF of 18 and 24, what I'm going to do is I'm going to make a chart for 18, and I'm going to make a chart for 24. And my chart is going to include all possible factors. So I'm literally going to start with 1. Okay, so let me just get the calculator up here so that way we can use it. So right here, if I start with 1, 18 is divisible by 1, so I get 18, so that works. So 1 and 18 is a set of factors. 18 is divisible by 2, and if I divide 18 by 2, I get 9. Okay, 18 is divisible by 3, and if I divide 18 by 3, I end up getting 6. 18 is not divisible by 4, and if you're not sure about it, you can just go ahead and do the division and see what you end up getting, and you get a decimal. So it's not evenly divisible, and 18 is not divisible by 5 either. So the next number we have is 18 divisible by 6. It's 3, but we already have that here. So as soon as you get to a point where your numbers are starting to repeat, you don't have to put them in your chart anymore. Okay, now let's do the same thing for 24. 24, when I divide 24 by 1, I get 24. 24 is even, so I can divide it by 2, and if I do, I get 12. I can divide 24 by 3, and I will get 8. I can divide 24 by 4, and I will get 6. And then I can divide 24 by 5 and get a decimal, so it's not possible to divide 24 by 5 evenly. 24 is divisible by 6, but it's already in my chart like we have here, so I'm not going to include that. Now the greatest common factor, there are common factors. 1 is a common factor. 2 is a common factor. 3 is a common factor. And 6 is a common factor, but we're looking for the greatest one, so the greatest common factor is going to be 6. So right here, my greatest common factor of 18 and 24 is 6. Now divided by the GCF, if I divide 18 by 6, I get 3, and if I divide 24 by 6, I end up getting 4, and then I'm good to go. Those are my answers here. Okay, so now that we've done that, let's go ahead and do the same thing for 13 and for 26. So let's make a chart for 13 and let's make a chart for 26. So for 13, I can divide 13 by 1, and 13 is a prime number, so that's all I can divide 13 by, okay? 26 I can divide by 1, and I get 26, and I can divide 26 by 2, and I'll get 13. So my greatest common factor of 13 and 26 is 13. So right here, when I divide by the GCF, if I divide this number 13 by this 13, which is my GCF, I get 1. And if I divide this 26 by this 13, I end up getting 2. Okay? All right, so steps to finding GCFs of monomials. A monomial is just one term. So the first thing I'm going to do is I'm going to find the GCF of the coefficients. And the coefficients, you guys, are just the number in front of the variable. Okay? Then once I do that, for each variable, I'm going to look for this is really important, I'm going to look for the lowest exponent in common with each base given in each monomial. And I'll explain to you guys what that means right now. Okay? So let's take a look at number 3. Number 3 has invisible coefficients. There's an invisible 1 here and an invisible 1 here. So the GCF of 1 and 1 is just 1. Okay? And then what I'm going to do is I'm going to see I have a base of x to the power, I have a base of x here and a base of x here. And they have the same base. So I'm going to look at my exponents, and my exponents are 4 and 7. And like the video said, we're looking for the lowest exponent. So the smallest number between 4 and 7 is 4. So this means that the GCF is going to be 1x to the power of 4. Now the 1 is not necessary. We can just say it's x to the power of 4. If I can't divide by my GCF, then it's not the greatest, then it's not a common factor at all. Okay, so let's take a look at what we need to do to divide by the GCF. So the first term that I see here is x to the power of 4, and I'm going to divide it by my GCF of x to the power of 4. And anything divided by itself is always going to be 1. Okay, then for the next term right here, I have x to the power of 7. And I'm going to divide that by x to the power of 4. So let's talk about what this means right here. X to the power of 7 means x times x times x 7 times. And x to the power of 4 means x times itself 4 times. And then when I have things that are being multiplied together, I can cancel stuff out. So I can cancel out this x with this x, this x with this x, this x with this x, and this x with this x, and I have x to the power of 3 left over. So right here, x to the power of 7 minus x to the power of 4 is x to the power of 3. So this gives me x to the power of 3. Now what's the shortcut? All you need to do is subtract exponents when you divide. Just like we add exponents when we multiply, we're going to subtract exponents when we divide. Okay? And that's how you do question number 3. Okay? So let's take a look at question number 4 right here. So for question number 4, the first thing I'm going to do is I'm going to look at my coefficients. So my coefficients are 8, 4, and 2. And the greatest common factor of 8, 4, and 2, the biggest number you can divide 8, 4, and 2 by is 2. So I'm going to have 2 right here. Okay? Then I'm going to look at each of my bases. So I've got x to the power of 3, x to the power of 2, and just x right here. And this has an invisible 1. And like we said, we're going to look for the lowest exponent. So if we have a 3, a 2, and a 1, the lowest exponent that we have is a 1. So it'll be 2x to the power of 1. Okay? Now, if you guys notice right here, the C in GCF stands for, the C stands for common in GCF. Okay, and there's no y in common, so there's no y in my GCF here at all. Okay, so now that I've done that, what I need to do is I need to divide every term by my GCF. So first term I'm going to take is 8x to the power of 3, and I'm going to divide it by 2x to the power of 1. So when I do that, 8 divided by 2 is 4, and then when I divide, I need to subtract my exponents, so 3 minus 1 is 2, so I get 4x to the power of 2 here. Okay, now let's take the next term, which is 4x squared. Okay, so I'm going to take 4x squared, and I'm going to divide it by my GCF, which is 2x. So 4 divided by 2 is 2, and then x to the power of 2 minus x to the power of 1 is x to the power of 1. So I get 2x right here. Okay, and then let's take our last term, which is 2xy, and let's go ahead and divide that by our GCF right here, which is 2x right here. So let's go ahead and do that. So 2xy divided by 2x. 2 divided by 2 is 1. X divided by x will cancel out completely, and then there's a y left over. So we can just say 1y. Okay? So that's how we do that right here. Okay. So now, what does this have to do with anything? You're going to see right now why we're doing all of this stuff. So the next question, number 5, says to distribute. So it says 3x times x to the power of 3 plus 8x squared plus 4. Okay, and if you notice right here, what I'm going to do is I'm going to distribute this 3 through, because that's what the directions say to do. They say to distribute. And this is 3x to the power of 1. So 3x to the power of 1 times x to the power of 3. This is 3 times 1, which is 3. And then when I multiply, I need to add my exponents, so I get x to the power of 4. Then I'm going to do 3 times 8, which is 24. And then x to the power of 1, x to the power of 2 gives me x to the power of 3. And then lastly, I'm going to do 3x times 4. So 3 times 4 is 12. And then the x just tags along. So this is what I get right here. Okay, now question number 6 says, what is the GCF of each term in your answer? So let's find this GCF. So the first thing I'm going to do is I'm going to look at my coefficients. So my coefficients are 3, 24, and 12. And the biggest number that I can divide 3, 24, and 12 all by is 3. Okay, then I'm going to look at my exponents. So I've got x to the power of 4, x to the power of 3, and x to the power of 1. And remember, we always look for, again, the lowest exponent. And the lowest exponent here is x to the power of 1. So my GCF is 3x to the power of 1. Now, I want to divide every single term that we have here by 3x to the power of 1. So my first term was 3x to the power of 4. I'm going to divide that by 3x to the power of 1, and 3 divided by 3 is 1, and x to the power of 4 divided by x to the power of 1 is x to the power of 3. So 4 minus 1 gives me this 3 that I'm looking for here. Okay, the next term is 24x to the power of 3. Right here. I'm going to divide that by my GCF. So 24 divided by 3 is 8. X to the power of 3 divided by x to the power of 1 is x to the power of 2. And then the last term we have here is 12x. And I'm going to divide that by 3x. And 12 divided by 3 is 4. And the x's cancel each other out. So based on that, we should notice something interesting that happened here. So right here, our GCF was 3x, and if you look at your problem right here, there's a 3x right there. Okay? Then, if you notice, all of our terms were x to the power of 3, 8x squared, and 4, and that's what we have inside of here. So pretty much when you are factoring by GCF, you're pretty much just undistributing. And that will be very useful to us in the future when we actually apply this to some of the quadratics that we're doing. So factoring by GCF is just essentially just undistributing. Okay, so let's go ahead and move on to the next part right here and see how we can apply this. Okay, so how do we factor by GCF? The first thing we're going to do is we're going to find the GCF. Then we're going to divide by the GCF, just like we've been doing all throughout this video. And then the last step I'll help you guys out with once we get to that point. So if you take a look right here, in question number 7, I'm going to find my GCF first. So the GCF, I'm going to look at the coefficients first. So 4, 24, and 12. So the largest number I can divide 4, 24, and 12 by is 4. Okay, and then I'm going to look for the lowest exponent. So I've got x to the power of 4, x to the power of 3, and x to the power of 1. So my GCF is going to be 4x to the power of 1, or just 4x. Okay, now what I'm going to do is I'm going to divide every single term by 4x. Okay, so right here my first term is 4x to the power of 4. And I'm going to divide that by 4x. So when I do that, 4 divided by 4 is 1, and x to the power of 4 divided by x to the power of 1 is x to the power of 3 because we subtract our exponents. Okay? The next term that we have is 24x to the power of 3. And I'm going to divide that by my GCF, which is 4x. So 24 divided by 4 is 6. So I get 6x to the power of 2 because we can just subtract it. And then our last term that we have here is 12x. So I'm going to take 12x, divide that by 4x, and 12 divided by 4 is 3, and the x's cancel each other out. Okay? So now what I'm going to do is I'm going to write my answer out. So if I factor by GCF, what I'm going to do is I'm going to write my GCF out in front right here. And then I'm going to say it's being multiplied by x to the power of 3 plus 6x squared plus 3. And that's what I'm doing when I'm factoring my GCF, because remember what you're doing is you're just undistributing. Okay, so when you factor by GCF, you're going to write your answer as the GCF times the quotient. And just a reminder that the quotient is your answer after you divide. So now, if I take a look at this right here, if I were to go through and distribute this 4x through right here, I would get this answer up here. So if you want to do that as a check, you absolutely can. Just be aware that this right here is the final answer. Okay? All right, so now all the steps that I showed you guys in number 7, you don't have to show all of those steps out. We can just do it all in one line right here. So I'm going to show you how we can do this a little bit faster. Okay, so the first thing we need to do is step 1 is still to find the GCF. So what I'm going to do is I'm going to look at all of my coefficients, and I'm going to see what's the largest number I can divide 3, -9, and 18 by, and that number is 3. Okay, then I've got x to the power of 1, x to the power of 2, and x to the power of 3. And the lowest number between 1, 2, and 3 is 1. So this will be 3x to the power of 1. Now there are y's in common right here as well. So y will be part of my GCF as well. And my exponents here are 3, 2, and 1. So the lowest exponent in common with the y's is 1. Okay? Now I'm going to divide everything by 3x to the power of 1, y to the power of 1. So 3 divided by 3 is 1. X divided by x will cancel out. And y to the power of 3 divided by y to the power of 1 gives me y to the power of 2, because 3 minus 1 is 2. Okay? Next, the next term that we have is this -9x squared y squared. So -9 divided by 3 is -3. X to the power of 2 divided by x to the power of 1 is x to the power of 1. Y to the power of 2 divided by y to the power of 1 is y to the power of 1. Okay? And I'm done with that term. Last term is 18x to the power of 3 divided by 18x to the power of 3y to the power of 1 divided by 3x to the power of 1, y to the power of 1. So 18 divided by 3 is 6. X to the power of 3 divided by x to the power of 1 is x to the power of 2. And then y to the power of 1 divided by y to the power of 1 cancels. And this is my answer right here. So I could just say it's 3xy. I don't need the invisible ones. I don't need this one here, so I can just say it's y squared minus 3xy. I don't need these ones here, plus 6x squared. If you have any questions about any of these problems that we've looked at here, please make sure to ask me. I know some of this stuff is very challenging. So please make sure to ask me so we can make sure you're staying on track with how well you guys have been doing this unit. And we'll make sure that you're good to go with all of this stuff. All right, I will talk to you in class. Have a great day.